This video is going to talk about how to set up story problems with variables on both sides. Let's go ahead and get started. Here's our first example. Kevin will choose between two restaurants to purchase pizza for his party. All right, very first thing to know, whenever you're comparing two different things, it is very likely that you are going to have variables on both sides. So he's choosing between two restaurants, variables on both sides. The first restaurant charges a delivery fee of $2 for the entire purchase and then $12 per pizza. So $2 for delivery fee, $12 for each of the pizzas. The second restaurant charges a larger amount. They charge a $6 fee for delivery, but they charge a smaller amount. They charge $11 per pizza. Okay, so there's some trade-offs between these two pizza joints. So the question is, hey, how am I going to compare them? Well, what I would need to do is I need to set up an expression that represents how much each of them are going to charge. For each restaurant, write in an expression for the total charge of purchasing X pizzas with delivery. Okay, so let's go ahead and get started. What is the total charge from restaurant 1? Well, for me, the total charge, I'm thinking about everything I have to pay. So for restaurant 1, I have to pay $2. Is there anything else I have to pay? Well, yeah, I have to pay for pizza. So I have to add to that 12. Now, how many times am I going to add 12? 2 plus 12, that's going to give me 1 pizza. Plus another 12 would give me 2 pizzas. But since I don't know how many pizzas that Kevin's going to be purchasing, I'm going to remember that 12 plus 12 plus 12 plus however many 12s is repeated addition, and I'm going to write an X after it, saying if he bought 3 pizzas, I would times by 3. If he bought 5 pizzas, I would times by 5. So we would say 12 times X. And that would be my expression for restaurant 1. For restaurant 2, what do I have going on? Well, they would pay a $6 fee up front plus $11 per pizza. So 11 times X, depending on how many pizzas he chooses to buy. And those are my two expressions. That's all I need to write. Now, if I need to compare my two expressions, if I want to know when the two totals are going to be the same, remember same is another name for equal. So when it says write an equation to show when the total amount would be the same, that's saying write an equation to show us when the total amounts would be equal. Well, total amount number 1 is 12 plus 12x, and that's going to be equal at some point to restaurant number 2, 6 plus 11x. That would be my equation, and from there I could solve this equation and compare the two. For this assignment, all I need to do is be able to write those equations. So there's example number 1, and we're going to move on and practice writing some more. Trey received a gift card of $100 for a pizza restaurant. Must be hungry. I like pizza, I guess. The restaurant charges $15 per pizza. Okay, Trey received a $100 gift card, and the restaurant charges $15 per pizza. Yoko received a $70 gift card for a different pizza restaurant, and that restaurant charges $10 per pizza. We're just comparing who maybe should buy that pizza. Okay, what's the better deal? Who's going to have some money left over? For each card, write an expression for the amount of money left on the card. Okay, so amount of money left on the card. Well, if I want to know how much is left on the card, I need to write down how much it starts on the card. So for Trey, he starts with $100. Now, if he orders pizza and uses this gift card, is his amount going to go up on his card or go down? Well, remember, we use the money on a gift card, so it's going to go down. So minus 15. That would just be for one pizza, but if he buys multiple, he has to times it by however many pizza he's ordered, so 15x. So that's Trey's card. For Yoko, she starts with 70, and she's also using money, so subtract 10x because she's buying $10 pizzas. Those are my two expressions, and to write an equation, of when they would be the same amount, I'm just going to say, okay, Trey is going to equal or be the same amount at some point to Yoko. Solving that equation would help me figure out when. Okay, we're going to try one more together, and then I want you to try one on your own. An air traffic controller. An air traffic controller is tracking two planes. To start, plane A was at an altitude of 486 meters, and plane B was just taking off. Plane A is gaining altitude at 18 meters per second, and plane B is gaining altitude at 27 meters per second. So let's write in an expression for each plane for the altitude of the plane after X seconds. So plane A, altitude of plane A. Let's go back to the story problem. It says plane A was at an altitude of 486 meters. So that's where they started in this scenario. Okay, continuing to read about plane A. Plane A is gaining altitude at 18 meters per second. If he's gaining, is that an increase or is that a decrease? Gaining is an increase. So I'm going to write plus 18 meters per second. So I would write plus 18 for 1 second, plus 18 for another 18 for 2 seconds. And since that's repeatedly happening, I'm going to write X. Remember, things that happen repeatedly, or when you see the word per or each or every, I'm going to put an X after that. And altitude for B, well, it says plane B was taking off. So if plane B was taking off, they had no altitude. So I'm not going to write a starting point. But the plane B is gaining altitude at 27 meters per second. So repeatedly adding 27 gives me 27x. So that's altitude for B. Write an equation to show when the two planes would be the same altitude. Well, if I want to know when they're going to be the same, that's another word for equal. And I'm just going to set them equal to each other. 486 plus 18x equals 27x. All right, this last one, try on your own. Pause the video, and when you're ready, go ahead and press play. Dan and Deborah each opened a savings account today. Dan opened his account starting amount of $710, and he is going to take out $45 per month. Deborah opened her account with a starting amount of $850, and she is going to take out $65 per month. All right, let's go ahead and get started. Amount of money in Dan's account. Well, he started with $710, and he's going to take out. So take out is a decrease. So take out 45x because he's going to repeatedly take that out. See that word per month is telling us that's going to happen repeatedly. Deborah started with $850, and she's going to take out minus $65. Now, Dan may have started less, but he is taking out less. So at some point, these guys are going to have the same amount of money. So write an equation to show when the two accounts would have the same amount. 710 minus 45x equals 850 minus 65x. And that would be my final answer.